All right, today we are simplifying expressions with rational exponents. Remember, our rational numbers include our fractions, so we're looking at like fractional exponents. So when I have x to the 1/2 power, what this really means is the square root of x, okay? And what that bottom part, I guess, what that bottom part means, when I have x to the 1/2 power, the bottom part is what we call the root, and the top part is your exponent. Okay? So another way to write this, and we have not been writing this all these years, is we put the root here, we put the base inside, and then my exponent can go one of two places. I can put that exponent outside here to the first power, or I can write it like this. It means the same thing. Okay, so the exponent can either be the exponent of the base or the exponent of, but that top number, the numerator, is always going to be your exponent. The bottom is going to be your root. So if I have, and what that means by the root is what number times itself equals x. Well, if I have something like this, what do you think it's going to look like? Yes?
The 3 in the little triangle.
Yeah, the 3 in the triangle part. And what that means, what number times itself 3 times equals x. Does that make sense? Okay. And if I have something like this, what do you think this means? Anthony?
Well, it'd be like the 4 right next to the square root.
And we say the 4th root of x. Or we say the cube root of x. What if I had a 5, a 1/5? X to the 1/5 power. Right, it would mean the 5th root of x. Does that make sense? Okay. All right, so right away when I simplify these, I'm going to put them into their root. Okay, what kind of root is this going to be for number 1? Yep. It's a cube root. Oops. It's a cube root, and I'm looking for the cube root of 8. What number times itself 3 times is equal to 8 miles? 2. 2 times 2 times 2 equals 8, right? Okay. Okay. Number 2. Again, I get real lazy. What kind of root is this? A square root. And it's the 16. And what would the answer be? 4. Okay, why don't you pause the recording? I want you to do 3 through 6 on your own. All right, so let's check our answers. For number 2, you should have had the number 4. Okay, for number 3, what was the answer, please? Vivian? 2. Okay, next one. For number 4, what was the answer, Edward? 3. For number 5, let's go, Jacob.
2.
Good. And everybody understands how I'm writing it. Jacob?
I got, for number 6, I got 5.
5. Okay, you guys good?
Yeah.
All right, so what about negative numbers? Let's do the same thing. I'm looking at the square root of negative 16. What would the answer be simplified to? Yep. Not a real root, because no number times itself equals a negative. Okay, what about the next one? Jacob,
-3.
how do I set it up?
The cube root of -27.
Good. Cube root of -27. And now we say that the answer is -3. Why are we allowed to find the cube root of this negative number as opposed to we couldn't find the square root? Kate.
Because if you multiply -4 times -4, it's positive 16. And when you multiply -3 times -3, it's positive 9 times -3 again, it's like 7.
Is there anybody that can we make a general rule here? Yes.
When the root is even, it's not a real root more than
When the root is even, an even root, it will be not a real root. But if it's an odd amount, we can take the root of a negative.
Actually, it's called the exponent on exponents.
What'd you say?
If it's an even exponent, then it's no real root, but if it's the odd exponent.
But like the root of the fraction.
But the root of the fraction is what we're talking about. You're right. Okay, so you guys do 3 and 4. Go. Pause the recording. Chris, number 3.
-2.
Okay, so I'm taking the 5th root of 32, and that is -2. Number 4, Charlotte.
Not a real root,
Not a real root. Why?
because the exponent is 1/4, and that's odd. I mean even.
Even. And we can't take the square root of an even number. I mean, a negative even root. Okay. So this is a lot of the same, so I'm going to skip it. You know, and let's move on to when we have. A lot of times they tend to use the same numbers, you know. Okay. I've already talked to you guys about this. It doesn't matter if we take the root or the exponent first. It doesn't matter. Okay, so when we have 8 to the, we can do this in 2 different ways. Now, my personal preference is I know that it's a cube root of 8, and I'm going to square it. Right? So what is the cube root of 8? 2. And then we're going to square it, and so it's 4. But I can also do this. I can say, I can take the cube root and square 8 first. So I can take the cube root of 64. What I don't like about that is I get bigger numbers. So what number times itself equals 64? Yes? 4. Should be the same. The way you do it doesn't matter. Is that clear? They're just not putting it in root form. Okay, so let's do 1 and 2. You get to do it however. Do you want me to do the first one? Okay, I'll do the first one. You guys do 2 and 3. Okay, so I'm going to first say I'm taking the square root of 9, and then I'm going to cube it. So it's 3 cubed is 27. So you guys do 2 and 3. Go. Pause the recording.
Number 2.
Okay, so let's check our work. Yep. Number 3. Yes, Alex?
I got 125.
So the root's 5 and it's cubed. Yep. Okay, and if you happen to do the other one, here we go. Okay, I would like to go to look at page 403. No, I want to take a couple different examples. Actually, I'm going to first go with our first page tonight. It's 494. And I want to do, you don't have to turn to it, I'll write it down. Shh. Okay, I'd like to do number 14, which is the cube root of 125. I've got m to the 9th, n to the 12th. M to the 9th, n to the 12th. So what I'd like to know, it's like taking the cube root of 125, the cube root of m to the 9th, and the cube root of n to the 12th. What is the cube root of 120? This is page 494. Number 14? 14. Okay, what's the root of the cube root of 125? Harrison? 5. Now, how many groups of 3 m's do we have? M times m times m. How many groups do we have? Cheyenne? 8? This is a 9.
Oh, no.
Shh. No, how many groups of 3 do we have in there? 3. How many groups of 3 do we have in n to the 12th? We do not have, we have more than 3 groups of, we have more than, how many groups of 3 do we have in n to the 12th? 4. So what am I really doing, guys?
Divide.
We're dividing by the root. Does that make sense? Okay, so that's one type of problem. If it's a 4th root, you're going to say how many groups of 4? Okay, now, what about if you have something like
Number 6.
okay, let's say you have 81 to the 1/2 power and then cubed. What am I doing with those exponents? Shayna?
You could, add it.
When it's outside inside, we're taking a power to a power, and the rule is multiply the exponents. So that's 81 to the 3/2 power. Okay? Which really means the root of 81, and then we're going to cube it. So it's 9 cubed, which would be 9 times 9 times 9 is 729. Yes?
Is it okay if you just do 81 to the 1/2 power?
Sure. But I just wanted to show you these exponents. They take the same properties that we used to have, that we have with our exponents. So, for instance, let's go now to 503. 503 is the most difficult. You don't have to do all of them. Try, see if you can go as far as you can go. Now, notice on, let's look at number 3. I've got 10 to the, what does it say, the 1/4 power, and 10 to the 5/8 power. What am I doing with my exponents? Yes? Nope. They're not outside inside parentheses. So what do? We add the exponents. But remember this. We have to have a common denominator. So I'm going to have to do 2 over 2, right? So I'm really get 10 and 2 over 8 plus 5 over 8. That makes what? 10 and 7 to the 7/8 power. And then we know what to do from there. It becomes the 8th root of 10 to the 7th. Yes? And that's as far as we go. We're just simplifying them. Okay? Now, and it says write it in radical form. What's happening here? When I have 2 to the 7/4 power over, hold on, 2 to the 3/8 power. Sorry, whoops. They should both, but yeah. What would we do? Anthony? Right, 2 to the 7/4 minus 3/8. Okay? If you have it outside, inside, it's a power to a power. Go as far as you can. Don't kill yourself on page 503.
How far do you say?